Alrighty, welcome to the Federation demo session. We are about to begin shortly. So if John from Dominode could come up.
So, good morning. My name is John Toohey, and I'm the CEO and co-founder of Dominode. And I'm going to give you a little demo today, mostly on PowerPoint, of our regulated identity product that's designed for professionals in regulated industries. But just as a small segue, so one of the speakers this morning talked about mainframes and logins and really alluding to these mental models that we all have about how computer systems work, what passwords are for, what login IDs mean. And today, in this age of decentralized apps and systems, most of those models are wrong, and some of them dangerously so. And most people here at this conference recognize that, particularly around the fields of identity, authorization, authentication. So as a segue into that, 1876, I believe, the telephone was invented. And almost 50 years later, the Bell Phone Company felt compelled to publish this, how to use a telephone. And these are the challenges we're facing today around mobile identities, decentralized applications. We have customers, consumers, we have software developers that fundamentally don't understand how these things work. And they're bringing old world models into a new world. So when we talk about Dominode, exactly what we're doing, we're looking at identities in regulated industries for professionals. So 1 in 4 Americans today work in regulated industries. 40% of workers, is estimated by the Department of Labor, will be in the so-called gig economy by 2020. And the way we define a professional in a regulated industry is if, in order to perform your profession, no matter how competent or how well qualified you are, if you need permission from the government to do it, and if you don't have that permission, it's probably illegal. So that is a professional in a regulated industry. So that's who we're focusing on. It's the very high end of a pyramid of regulated identities. And it's also quite difficult because if the government has to grant you permission, the government are going to make this permission as painful as possible, right? Layers and layers of bureaucracy. Some of the industries we're looking at working right now, this is just an example of the documentation you have to provide to the government in order for them to vet you. So security, photographs, college transcripts, military records if you have them, residence cards, driver's license, and all of these credentials have to be verified and vetted by those government regulators. And they're not just static, because if you look at a lot of these things, they have expirations on them, so you're constantly updating your professional identity in order to work. So talking to some of our customers, these are some of the comments that we get on a regular basis. They're executives in large companies, they're traveling, and their compliance departments are calling because an update to their documentation is required. They're getting subject to credit checks that are sometimes hard credit checks, and their credits are getting dinged because they're regulated in many, many different jurisdictions. Take an example of telemedicine today. Before, we had a doctor that worked in one state and was licensed in that state. With telemedicine today, he must be licensed in every state that his patients are in. So this requires this constant update of data, this constant check. A lot of these guys are subject to random drug tests over a year. If you're regulated in multiple jurisdictions, that's multiple drug tests. So that's one of the things with Dominode. So this is the problem space that we're moving into, and solving that with a self-sovereign, private, portable digital identity. So the way it works is that your employer would basically push out an app to you, our app. And the onboarding process is fairly simple to begin with. We require you to take a selfie, and during that process, we check for liveliness. We check that your eyes are blinking, right, that you're not taking a photograph of a photograph, and then require you to upload a physical document that has your photograph on it that has been issued by a government agency. So a driver's license or a passport. We then compare the two photographs, and that's the first step in us verifying your identity. We then ask you to upload other documents that are required depending on the industry you're in. Those documents are then digitalized, encrypted, and then we use trusted third-party verifiers to verify that data. So it could be the regulator themselves, it could be a company like LexisNexis, large trusted parties that can actually look at some of this information, digitally sign the credential, and it comes back to your app. Your employer then can bind your identity to their back offices through a digital identifier that's on the phone, And that allows them to look at all your claims about your identity and then to use those claims to apply on your behalf for a license with the regulator. So this is what the claims look like in your app. So you have a number of cards here, your biographical data, your citizenship, your education. And behind all of these claims are proof documents, which are the physical world documents that back up college transcripts, driver's license, passports, etc. And then each of these claims then is verified by, like I said, an external third party. So they're self-asserted claims to begin with, and then we verify them. And then once they're verified, digitally signed, if you're licensed in multiple jurisdictions, other regulators can simply use the verified claims. So that cuts down as a big burden reduction on their side. They don't have to spend time and resources re-verifying something that another government agency has already done. On the business end on the platform then, this is an example, this is one of the backups that your employer would have. Once you bind your identity to this platform here, they then have access to these claims which they can re-verify on your behalf. So HR will check maybe that you did go to the college you said you went to. Once they verify that, they can sign your claim, and that then becomes part of your ongoing digital identity. The regulators or oversight agencies, they get to see here, this is the example of your college transcripts, and they get to see who else has verified that in the past. And if it's anybody on this list that they have already trusted because they've accepted verifications from before, like I said, they will accept these verifications again. They're also allowed, obviously, to re-verify everything you say. If they do that, then there's more digital signatures on your claims, and that increases your credit score, your trustworthiness within the digital ecosystem. So that score there of a 10, that means somebody has been verified, re-verified, and always by government agencies, trusted third parties. And those verifications have been used then to grant them a license or permission to do something. Am I doing time? That's what I've left, or that's all I've done? Oh, it's okay. It's like 3 minutes. Yeah, so there's our ecosystem. So Dominode provides the software. So the individuals themselves have this app, and they also have an agent or a hub that's under their control in the cloud where we store all these claims. We use third-party vendors, again, Experian, LexisNexis, Quest for the drug tests. And then on the outside then are the government regulators. And these examples here are all from the gaming industry, the state of Nevada, UK Gaming Commission, etc. So we're also members of the Decentralized Identity Foundation, and this is their mission statement, and our architectures, our software designs are all based around this. So decentralized identities, we anchor them on blockchains, and we link them to these zero trust data stores, which is the cloud or a data center agent that's controlling your identity. These agents are universally discoverable, but everything on the agent is completely encrypted, and the private keys that unlock your claims are stored on your smart device. So you're in full control of your identity at all times. If somebody tries to access an agent to retrieve a claim about your citizenship or your right to work in a certain state, the agent will respond by sending a push notification to your smart device. You will be allowed then to use a biometric to release that claim or deny it. If it's released, it gets released for 30 days or 60 days, whatever time period is set up. And then the agent then will release that back to whatever other agent has made the request for your claim. So I think that's it. You guys have any questions or?
The trust scores you were showing, were those for the verifier or for the claim, or?
Okay, so the question is about the trust scores, the Domino's identity. So we have an algorithm, and you start off at 0. We're showing 10 on that one today, but so far it's been impossible to get a 10 out of the algorithm. But basically, it's a score that goes higher and higher with the more verifications you have, and also the types of verifications. So one example is if you produce a passport as a proof of citizenship, that's good. So we'll give you a score for that once it's been verified. If you are a naturalized citizen, you've gone through maybe 5 or 6 years of intensive background checks by the federal government, we give you a higher score for that. If you have a global entry card as part of your digital identity, that increases your score. So the more trustworthy or the more higher value that your credentials are, the higher the score goes. Now the score is dynamic, it can also go down, right? So if you get a bad credit score, if you get arrested. I mean, if you declare bankruptcy, those scores will dynamically go down because that stuff has been tracked as well here.
Who verifies the passport?
The State Department. So that's so we verify that it's a real document, and then so normally what we do is the whole process is not automated because we're not trying to replace everything that's out there today. So if you're a regulator, you have a process today if you require a passport to verify that. So most of the state regulators that we've talked to will call the State Department to verify the information. But what's important to you as the individual is once they've verified it, the software, our software, will digitally sign that, and it'll be signed with your keys. So it'll say the state of Nevada has verified your passport, and that then comes back to you. And then the next time a government regulator tries to look at your passport, they'll see that Nevada has already checked it. They can check it again themselves, or they can simply accept the verification from Nevada. You good?
Yeah.
Just as I sit and do my demo, I will also use the chair. Great, thank you. Yeah, this is good, thank you. Well, thank you, everyone. I'm with ThreatMetrix. My name is Laura Kirkham. I'm a director of strategic accounts. Today, I'm going to tell you a little bit about anonymized global digital identity. Anonymized is the key word there. I think that's a little bit different than what you may have seen in different login workflows or account creation workflows, but just the latest and the greatest from us and how we do it. Over the past year or two, our product has really evolved. The solution itself has been recognized by market analysts, not only for identity assurance and identity proofing, but also risk-based authentication within account authentication workflows. So really what that means is, unbeknownst to the user logging in, be it Workforce or one of your customers logging in online, unbeknownst to them, we're able to profile and also show you more intelligence about the behavior we've seen online in the past, providing you with a risk analysis of our anonymous truth data. The same is true for payment transactions online. We've been in this effort for over a decade, starting out protecting online transactions for payments, and as the threat landscape has evolved, have also been protecting account creations online, as well as login workflows. So really anything that you want to protect online, we're able to profile and give you a behavioral analysis about what we know about them so you can make a better decision to either accept, reject, or review that transaction. How do we do that? Well, we have the world's largest crowdsourced global shared intelligence network. You may have logged in on Facebook before, or Netflix to watch your movies, even gone to Best Buy or Walmart to purchase digital goods or have something sent to your home, or maybe even called a Lyft to get over to the center today. As well, we're being used by some of the world's most respected and global financial institutions. So folks like Visa Checkout, Discover, Citibank. We're processing over 100 million transactions per day. So really, as the threat landscape changes, we're able to have that knowledge and intelligence for our customer base so they can pivot when needed in a very agile and easy way. But what is this digital identity network? You might notice here unique online identities. There's approximately about 3.5 billion unique identities online. We've seen 1.4 billion, and we know something about them, and we can bring that context to your online workflows. Same is true for unique devices, 4.5 billion. seems to me that most of us probably have 3 or 4 devices, and that's reflected in the intelligence that we have within our network. And it is a truly global network. 185 countries are served, over 6,000 clients, 40,000 websites use our profiling and digital context for their online transaction protection, but also at the same time allowing those good users to proceed through the login use case or the new account creation use case with less friction, so they can proceed with their online transactions without too much time and effort. What is digital identity to ThreatMetrix? We have 4 pillars of digital identity that is contained within it. The first is web and mobile device intelligence. It's really all about, what does that device look like? We have 2 unique identifiers, an exact ID, which is based on cookies, and a smart ID, which is based on the unique attributes of that device. We're able to pull about 784 unique identifiers from the device and the browser session to be able to look for anomalies and check for any behavior type changes within the device itself. That's called the smart ID. And it also has a cryptographic key that can be placed on the device, cannot be spoofed, cannot be wiped. It's a consistent and persistent device identifier. Number 2, identity and link analysis. How has that user behaved in the past? How are they behaving right now on your website, logging in or trying to conduct business? We're able to notate that in an instant when we do our check to the digital identity network and proceed with the risk analysis to you. Number 3, true location and behavioral intelligence. We can tell you the type of connection that user is on, pierce proxies, do secondary DNS lookups to confirm actual location. So if someone is trying to spoof their location, they're going to be very hard to hide. We're going to also be able to tell you if they're on a possible VPN connection, possible Tor network connection, and alarm you to that while the transaction is taking place. And number 4, botnet malware threat intelligence. Has this device been affected in any way? Unbeknownst to the user, is there malware on there? Is it being used in some kind of session hijack, bot attack, or remote access Trojan? These are all important things and should be weighted within the risk analysis that's delivered back to you. And so how is it implemented? Pretty simple and lightweight. We have 2 lines of JavaScript tags which are placed in either the browser or the mobile SDK, which for your mobile apps. As soon as that user calls up the application or goes online to transact, those tags are loaded. And unbeknownst to the user, we're gathering all that device and unique attribute information. And so we're doing this all anonymously. All the things that are not PII are being collected, and a session ID is assigned to this transaction. Once that user selects enter and transacts maybe that username and password, that information is sent back to the customer backend, and from there a RESTful API call goes out to our digital identity network. We run through the policies that have been set by you with the particular weights for your threat and risk appetites. A full score is delivered, as well as the reasons that that score totaled the way that it did. Now a little bit more about an in-depth demo. I'm just going to go over to my demo site. That's why I brought this chair. And so from there, talking about a use case and how that works in real time. So within 200 milliseconds, this risk score is delivered back to you. And I'm going to simulate bot detection and what that might look like from our system. Essentially, those tags loaded, the session ID was created, the RESTful API call occurred, and within 200 milliseconds delivered the score being a -100. We'll go from -100 to +100 on the score. The reasons why that negative 100 score occurred, one smart ID, that's that consistent and persistent unique identifier, to many emails. So it looks a little bit suspicious, like credential stuffing is occurring at that moment. And usually high velocity of logins are occurring. And the same is true with their OS spoofing. They try to hide behind different OS technology to obfuscate what they're doing. But really, what does that look like for us information folks? The API call request is very light, and the API call response is very heavy in detail. So what you'll notice is there's multiple avenues where we're checking device intelligence, the smart ID, the exact ID, the different policies and the scores that they had resulted to it. And then in here, what we're able to do is create variables that will allow us to get granular information on normal and abnormal behavior at the account level. So not just general populations, what's normal and abnormal behavior, but drilling down into the granularity of this actual account, what's normal and abnormal for them. And we have hundreds of variables that can be created in that way to be able to get that information back. Now, what does that look like on the portal side for your administrators? Essentially, the portal looks it's very straightforward. You see this negative 100 score happening multiple times, the true IP geolocation, all the different account names and account emails that have been attached to that user login, and then the different OSs. So you see this HTTP signature and the OS aren't matching as well. So in a nutshell, that's how we determine good and bad behavior in 200 milliseconds for your live digital transactions. Thanks.
You deliver a score to your client,
A score with the reason codes.
and then they will make their own decision.
So we have DigiMe presenting, so thank you.
Sure.
Yeah. Our dongle got used yesterday, never got it back. Thank you. I'll make sure you get yours next.
Oh, that's good.
You're on. Hi, everyone. This is Shane Green. He's CEO of DigiMe US. I'm Tarek Kurspahich. I'm the EVP for technology. And we thought we'd just take you through an actual demo of how DigiMe works and explain a little bit about what it is.
That's great. We're actually we're going to start with just a video that is actually going to be playing in Europe. We're a London-based company, but the operations around the world, including in Australia, the U.S., and across Europe. And we just thought it would be fun. Maybe those of you who were at the hackathon yesterday might have actually seen the oh, there we are. Seen the debut of it, but it's a fun statement of what we're about as a company, and I know we're generally among sympathetic audiences here, but this is part of the mission that we have to try to convince people that they need to become proactive in managing their data. So enjoy. Let me get it back to you. Great. That's short, that's simple. And in Europe, this sort of messaging is really been around for a while now, and I know a lot of you are familiar with that, but it's a very exciting time. Lots of companies, lots of developers looking at ways to build on platforms that can actually empower users. So what I wanted to do, I just wanted to really dive into some live demos and show you guys kind of how it works. But feel free, if you have any questions, to just raise your hand along the way. This is my actual DigiMe app, and I'm going to just, before we getting into the data that I already have, just give you a sense of the kinds of data connectors that we have. And this is a big part of our business, is just finding every source of data out there that you might be interested in having a copy of, or developers and third parties that you're going to repermission it to. So everyone from 3,000 financial institutions, Fitbit, Garmin, the 5 major social networks, Spotify. We have Health Now in Iceland, in the US, about to do it in the UK. But literally one half of our entire business is just finding as many different sources of data. So if you have some, please let us know. We're working to make it easier and easier for users to get that actionable, structured, reusable data into their DigiMe library. But what you actually see here, and I'll turn it over to Tarek for a moment before we show the data, tell them where this data actually lives and how the app sort of looks at security and privacy.
So as Shane said, currently we have social, financial, health, wearables, and fitness data. And what's really cool here is we don't have a central server that houses our users' data. We actually don't want to see, touch, or hold it. What we do is we empower each of our users to choose a location that's in the cloud, so it's cloud accessible. Currently we support Google Drive and we support Dropbox. And we're adding more what we call P clouds, personal clouds, places where you can house your data. And using the device, we create a set of a strong encryption. And after the user chooses their P cloud, they can start to onboard different connectors, services. So for example,
I was just showing them some of the Fitbit data as you're seeing them kind of doing real time.
Sure. Yeah, so if Shane chooses to add Fitbit, we have a set of stateless functions that run in the cloud, and his device will inject all the information that a function needs to go connect to Fitbit. It has a date range, it has the type of objects that he's looking for to pull down into his library. And we will pull that, we will encrypt it, and we will put it on his cloud, and then the stateless function disappears and everything gets wiped. So now Shane is walking around and he has all of his data when he's logged into the app.
Let's just, I want to make sure so they understand a little bit more before we get to the sharing piece. Again, you're getting, this is all my social data from Twitter. Hopefully those of you who were there yesterday got to see the grand prize winners of the hackathon, Digiport, who built on DigiMe, and Tarek's about to talk about how that works. But I'm actually getting a copy of this data, right? It's not, the Twitter doesn't have a copy of it, of course they do. I'm getting my own copy, and it's machine readable, structured, and as it gets reused with my permission by other third-party services, Twitter's no longer in control, right, of my data. And you can see that, you've seen the financial as I've been scrolling through, Instagram, literally all the major social networks. So this was our promotion for the hackathon, et cetera. So as Tarek now talks a little bit more about the sharing function, you can kind of get a sense that DigiMe itself, which is really not designed to be an app that you spend a lot of time in, it's really where you go to connect your data and reshare it, that data is available only to you. So we'll do the SAN demo now maybe, and you can talk it through while I do it.
So now that Shane's empowered with all of his data, natural thing to do with that is to put it to some use. At DigiMe, we'd like to be sort of the electrical grid for how this happens and just a set of tools. And we want our customers to really shine and create the apps that are going to make sense of Shane's data and help him live a better life or get services, et cetera. So we have an SDK, we call it Consent Access, and we call it Consent Access because the user is at the center here, right? It's a user-centric approach. So the app that he launched, we call it SAN, it's a social analytics app. It's going to have permission to access Shane's information. All of these requests come to the same screen, which is our permission screen. It tells Shane what type of data the app wants, who the app is that wants the data, what they want it for, gives them the terms of use, what they will and won't do with that data, and then Shane can authorize or reject the transaction.
I'm authorizing.
Good. So basically, once Shane authorizes, we can issue a session to the third-party app, and all of the data that fits the contract exactly gets delivered as JSON into the calling app.
And it's never leaving the device. I mean, in this case, yeah, it's really important, and it is part of the terms that you understand. It will let you know up front whether or not the data is leaving the device or not. In this case, it's not. It's really just an analytics app where I can have complete confidence that this third-party app with its analytics is reading my data. I can get the benefit of it, which I'll explain to you here, and then I shut it down, and they've never seen anything. They could ask for access to maybe the findings, not the raw data. They might actually ask for the raw data. That's incredibly transparent to the user right up front. Here, what you'll see is I'm a pretty regular social media poster. And again, this isn't just looking at Facebook or just Twitter or just Instagram. It's looking across my accounts. So the ability now to do analytics on data that's been normalized and standardized across any part of your life is just super interesting, creates whole new opportunities for us to be empowered with their data. But going even deeper, I can look at what time of the day I'm posting. And I did this, it was pretty funny. I was like, wow, I'm really not posting at all hours all the time. And my wife said, yes, you are. But we are based in Europe, so I'm actually, I think, according to my device, in the way it's capturing the time, it's sort of smoothed out in terms of I'm spending a lot of time here and a lot of time there, and I am posting a lot. But this seems pretty simple as a set of analytics. The next rev of this, which some of these features actually you can see already just in sort of a pilot form inside of our own app, is things like who comments most on your posts. That could be pretty interesting. It's infinite in terms of how many different things that which posts have I liked. Sorry, I'm sort of for the march on Saturday. If you don't mean to get into politics here, but if you're seeing that up there, so anything's really now possible with this, and we're plugging in, like I said, to more and more data sources all the time. I thought it would be interesting to show some of the apps from yesterday and the hackathon, and we're not going to actually demo them. Sorry, I'm trying to make sure I get there it is. But for those of you who were there, we were the sponsor of the hackathon. We're very excited because now developers can come in and start from the value proposition of, okay, this user has all of this data about themselves. What can I do with it as a value add on top of it? And so we had 5 finalists that are featured here: SmartBridge Navigator, Digiport, who was the winner, Betteroo, Fit for Pay, and Digital One. Each of these were, literally done within 24 hours. They were very, very innovative solutions, very different solutions. For example, Digiport was trying to take all of this authenticated data that's come in and create a very highly reliable identity using blockchain, again, extracting a lot of attributes that they could rely on and cross-referencing them between your bank account and your social media accounts and various things. Super interesting identity solution. They created it in less than 24 hours. Betteroo was trying to create, through that private scoring you saw, health insurance scores that could then be passed along without the raw data to help actually lower rates for your health insurance. And then the final one, Digital One, was just a really cool natural language interface to start talking to your data and say, hey, how much did I spend at Starbucks last month? Or when's the last time I got a tetanus shot? And as long as that data's in there, it could bring it back. So again, super innovative work by those folks. And then we also yesterday announced one of our first US-based partners. This is a separate company called DataVast. You might have seen them in the startup competition. Again, they're able to build on what we're doing. It was about getting cryptocurrency and capitalizing the value of your data. Super interesting business. Again, something that we're empowering, and would encourage you guys to think about ways you could use the platform too. Thank you.
Thank you, DigiMe team. And up next, we have Carlo from ProxToMe. Carlo.
Okay, very good. Thank you very much. My name is Carl again. I'm from ProxToMe. We are a company located in San Francisco with a proximity-based authentication technology for the Internet of Things. Our goal at ProxToMe is to make mobile interaction with smart things simple and safe. We know that today there are around 5 billion people that are mobile users. And tomorrow they will interact with over 20 billion connected devices. And any of this intersection, any of this interaction will start with the mobile user verifying the identity of the IoT device to decide whether or not to trust it and then communicate with it, or vice versa. We call it the first mile of the Internet of Things. Somebody else prefers to call it the last mile. Anyway, we think it is highly vulnerable to man-in-the-middle attacks. In other words, what can happen is when I'm using my phone to authenticate to a device that is in front of me, somebody can relay the messages to another device that is not in front of me, right? And so either I get control of the wrong device, or even worse, now somebody is using my credentials to access a device that is in the opposite side of the world. So this is very bad, and it's becoming, as a problem, it's becoming more and more prevalent as our phone is gradually replacing our home keys, our cards, our badges, right? And it's becoming the main authenticator to this new world of connected things. And the problem to us is even worse, because if we look at the market, nobody today can fix this problem without falling short on one of the two major pillars for best user experience: convenience and security. And we all know here that if you want more security, usually you have to give up on ease of use. There's a bunch of solutions out there that are relying on QR codes, passcode, ultrasound, Bluetooth, and so forth. They all struggle with finding a balance between convenience and security. And if they do find this balance, usually they're either limited to one device platform, or they require a large investment on the IoT device. And so that makes the solution quite unscalable. So what we have done at ProxToMe, we have taken what we believe are the best wireless communication technologies and came up with security and convenience all in one solution. The technology is a patented technology that combines proximity certification with identity assurance to establish a trust between the phone and the IoT device. ProxToMe is contactless, cross-platform, man-in-the-middle proof, and better yet, it is highly reliable, with no false positives when we are in high-density scenarios, where use cases where I have to discriminate one device from X other devices based on proximity. So this is how it works, and let's assume we are using our technology to provide a cardless access to an ATM. So we have an SDK that goes into the banking app. We have a custom firmware that goes into the ATM, and there's a backend component that goes on-prem in the bank server backend environment. The process in this use case starts and ends in the user app. We're leveraging Bluetooth and possibly NFC, if Apple allows us to do that, to determine physical proximity in very short range, and then trigger the identity verification of the ATM. So the output that we generate in the user app is like, hey, this authenticating user is a few inches from a federated ATM. We don't care about the authentication on the user app. That's provided by somebody else. We just handle the handshake between phone and ATM. So I have a demo here, but let me try to go to a short video that is no longer here. Okay. Okay, no. Sorry for that. Let me do this. Assume this is an ATM, a very atypical ATM, because it doesn't dispense money. Okay. I have here a simple mobile app where I log in, and when I'm in the app, I have the option to pre-stage the transaction. This is the trend, right? So instead of doing stuff on the ATM, you do your operations on your phone. So I pre-stage $100. Okay, this can be done in your at your house, right, at your home, in a secure environment. When I confirm the operation, I had this pending, right, transaction, and then I walk out and I go to an ATM. And when I'm the ATM, I'm using my phone and I do cardless access. This is when I start the proximity engagement with the ATM, and when I get very, very close to the ATM, boom, it gets me in. So I can build very different user experiences on top of this layer. Right now, what I'm doing is I'm recognizing Carlo right here, and I'm saying, hey, confirm that you want $100. But we can also push this beyond and say, maybe this is screenless, so just touch and get the money right away, right? The technology that we have here is very, right now it is Bluetooth. We can also do NFC. We are actually integrating that in the mix so that we can get very, very accurate, right? But there's no data flowing, there's no transactional data flowing over the physical channel. So it is fast. It takes less than a second to do the whole process. It is accurate. With Bluetooth, we stay within 2 and 10 inches. With NFC, it's even more accurate, as you know. It is secure, so the goal is to eliminate any man-in-the-middle surface attack surface, but also the data that we are passing over the physical channel is just a challenge and a response. And if you get a way to intercept them, I don't really care. It's totally valueless. It is easy to deploy, so we have different configurations depending on the customer needs. But the easiest one is where we go to the customer and say, if you have Bluetooth and NFC in your device, awesome, right? We give you our custom firmware and it's good to go. If you don't, we can give you a very small USB dongle that has Bluetooth, possibly also NFC, plus our custom firmware. You just need to power connect it, and that's it. As you can see from this slide, the framework here has no link between our custom firmware and USB dongle and our server component. Clearly, we can get to a more complicated, more complex infrastructure where we also add a link here and we generate keys per session and blah, 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 right? So we can actually, we had different configurations. It really depends on how fast we want to go to market. 2 minutes left. This is a technology that can apply to literally a huge variety of use cases. What I want to make clear is that we are focusing on interactions between untrusted endpoints. So this is not really adding so much value for accessing our Alexa at home, our speakers at home, or our infotainment in our car, where, I mean, that's more like a secure environment, right? This is a technology that really works when with your phone you want to access something that you don't have the time to pair your phone over Bluetooth or connect to the same Wi-Fi and so forth, right? So door locks, connected vehicles, sharing vehicles, ATMs, workstations, and so forth. Right now we have a focus on fintech. We're part of the Wells Fargo Accelerator in San Francisco, where we work around cardless ATMs. We're also approaching Bank of America. We are working with 2 European companies. They provide payment solutions for gas stations. And that's really interesting because, first, it's a way, ProxToMe can be a way to enable this payment from your phone at the gas station, from your car, since Bluetooth has also a broader range, so we can also pair, actually handle the handshake between your car and the gas pump. But also it is good for maintenance teams that have to unlock the gas station, the gas pump to do maintenance. So this company is really looking at this technology from different perspectives. P2P payments for with proximity-based interaction, that's something that we're trying to get into in printers. We'll be speaking at different other events in the next few weeks. So if you want to join us, we'll be happy actually to have you there. Thank you very much. We had 10 seconds. Do you have any questions?
And if you all have any questions for any of the demo session people, be sure to find them at their exhibit. And last but certainly not least, Mark from LexisNexis.
So good afternoon, everyone. Hope everyone's enjoying the conference. My name's Mark Bacon. I'm a senior product manager on our fraud technologies team at LexisNexis Risk Solutions. And today I'm going to be going through a little bit about our risk defense platform, what it can offer, how it works, and then I'll run through a number of demos using it. Hopefully I can get through all of them in the 10 minutes. I've timed it, so I think I can. So let me just jump right in past this nice cover slide that marketing created. So within the bags that you received for No Identity, you saw a postcard. This image was on it, and this is a good representation of what our risk defense platform truly does. So it combines our technologies in fraud analytics, in verification and authentication in the way that each individual customer needs. So they can purchase a specific product set from us, and then we can link all those products together using workflow and manage all the decisioning logic in between, which means that customers send us a single API call with PII, potentially a session ID. We can analyze device risk, behavioral risk, locate the identity in our system, perform verification on it, and then authenticate the user to ensure that the proper layered solution is in place for the amount of risk that that person is showing with the data that they are providing. So the demo that I'm going to go through actually, I created a little Visio diagram, and I'm actually going to go through each of the different flows here. So you'll see me fail a number of times. You'll see me go through and not get authenticated because I don't present any additional risk. And then I'll actually send it through an authentication path where, based on the phone number that I put in, it will verify my current mobile device and send me a one-time password. And then I'll change the number, and you'll see again, it'll dynamically convert me over to giving me a KBA quiz. So I get a little bit more friction and a little bit more of an invasive solution, but we weren't able to verify my phone, but we're still able to authenticate me. It'll determine if it passes, and so on. So let me jump right into that. And for doing this demo, I'm going to use our Bank of LexisNexis website. So what this is a website that we built on our server, but it doesn't connect to the platform directly. It's not part of the platform. It really, truly performs an API call from the code to our platform. The platform processes it, provides back data. The site reads the data and provides back a success or a failure. So what I'm going to do first is I'm going to just click our Apply Now button down here. And you'll see that a lot of my information is already preloaded. That's more for the demo. It wouldn't be something we'd recommend for our clients, of course. But this is all my accurate and current PII information. And due to that, it's going to go down that path where what we call in product often, I'm sure you've heard it, the happy path, right? It's going to verify all my information, validate me, see that there's no additional fraud risk, and then you'll see up at the top, my application was successful. Now, I'm only doing new account flows, but I could enter username and password and go into login and account update flows as well. The next thing I'm going to do is go in here and give it completely inaccurate data, and then it will not be able to find me at all. It requires a username, so that's sometimes a little bothersome. You might see me forget to put that in and get a nasty message. So I'll be Fred Flintstone at Bedrock Court. In Prehistoria, we don't have any regions of Pangea to choose in our state, so we'll say that's in Georgia also. I'll invalidate my zip code, and now it'll comb through all of our records and attempt to find me, but due to the fact that I've clearly put through a false identity, you'll see that I now fail. The next thing I'm going to do actually uses the technology that Laura was mentioning earlier with ThreatMetrix. So you'll see here that I'm in Incognito Mode. Now, for the purposes of a demo, Incognito Mode is what we use to present device risk. Now, of course, this is in a real use case. A bank wouldn't probably turn down an applicant because they're in Incognito Mode, but you heard in the presentation all the other things that that technology is capable of as well. So that the fact that I'm in incognito mode is just one of those nearly 200 attributes that are being extracted from my device. So I'll click Apply Now. I will still enter a username because I have to, but other than that, I won't change any of my data. So again, this is all my current and accurate identifying information, and I'll click Submit. And I fail. Even though I put in all good information, it was able to detect that I had device risk and force me down this path. Now, a bank might want to list why it failed you, so you can potentially not come back in through a proxy, not use a virtual machine, or they could just say to call their call center. Okay, so this next one I am going to do is back on my non-incognito mode browser. And I'm now going to go back, I'm now going to go in and, like I mentioned earlier, that was all my current PII information. So I'm going to introduce a little bit of risk into the flow now. And I'm actually going to put in an address I used to live at. So there was a point in time when I wasn't living out in the suburbs and didn't have a family, and I was cool and lived in Atlanta. So I'll use that address. And this phone number, notice, like I said, it is my current phone number. So when I click Submit this time, I told you I'd forget to enter the username at least once. So it's verifying that this is my current mobile phone number. We have connections into the major network operators. I just got a text message. I'll enter in the code I received, and my application is successful. So now I'm going to do essentially the same thing, but I'm going to change one digit on my phone number, so it will no longer verify to me. So I'm going to again put in my previous address. And I'm just going to change one digit here. Thank you. All right, and now because of that, I received a KBA quiz, so I can still be authenticated, just through slightly more invasive means. So we're adding a little bit of friction to me because I'm presenting risk that I wasn't presenting previously. So I'll enter information about myself, and I'm successful. So that's essentially what the risk defense platform does. It allows you to evaluate on a product-by-product basis as it goes through the workflow if any additional risk is being introduced into the application, and then either fail the user, pass the user, add additional authentication components, or push them into something like a manual review situation. And I want to mention that we're not focused entirely on banks. The reason is because it provides a kind of general opportunity in the industry that everyone's fairly aware of. You know, everyone goes to banks, they've seen it. So imagine this in your situation with whatever your UI looks like. You have some screen most likely where people are entering in PII, and that PII needs to go through. We need to determine the identity, verify that it all links together to that single user, and then go ahead and authenticate them. And then on top of that, we can do analytics around fraud, whether it be by device, whether it be through our behavioral biometric solution that we call behavioral assessment. And that does something around analyzing, and it's very difficult to demo because it analyzes my mouse and keyboard input, and it's very hard not to appear like myself when I'm actually using my peripherals. And then we can look through our data sets to see if there's any additional fraud risk. So that was evidenced by you're seeing me enter in a previous address, and that come back and introduce a little bit of additional risk into the flow. Let me see. I have a minute left. Does anyone have any questions?
Is ThreatMetrix already included in your...
Yes. So actually, about a month, it's been a month now, about a month ago. LexisNexis actually acquired ThreatMetrix, but we've had a commercial relationship with them for quite some time, and that's the technology that's embedded there. Yes?
When you say PII, what do you include in that? Do you include just your name, address, or do you include the behavioral biometrics? What's the scope of PII?
So it's dependent on the customer's use case. So it can be, name, address, phone number, social security number, driver's license, email. The behavioral aspect of it is actually all collected in an anonymized fashion. So it's just looking, do you look like you normally look? Are you typing at the speed that you normally type? Are you copying and pasting PII data? Like it can detect, are you going off page and coming back, off page, coming back? Are you entering your long number strings, like a phone number? Are you entering it in chunks? Like you don't really know it, you're kind of looking off screen and entering in 3 or 4 digits at a time. So that isn't really considered PII. That, along with ThreatMetrix's solution, utilizes JavaScript, and both of them use the session ID to ensure that they're kind of scoring the right session. I'm done? All right, thank you.
Thank you, Mark, and that will conclude our Federation demo session. Be sure to ask any additional questions that you have at any of our demo sessions exhibit spaces. They'll be happy to answer them for you. So thank you all.